Okay, problem number 3 on the 3.8 worksheet number 2. This is a worksheet I made to give you guys a little bit more practice at coming up with what I call general inverse derivatives. So the directions, which aren't really clear on what I've written here, are asking you to find the derivative of this function, the derivative of the inverse of this function right here, evaluated where a is equal to 8. So once you start seeing the keywords here of derivative and an inverse, that's when I want you guys to automatically start making a t-chart on problems like this. And what I want to do on the t-chart is on the left-hand column, I want to deal with the original function right here, which is f of x. And I'm not going to bother to rewrite that, but it's right there. And then on the right side, we're going to deal with the inverse of that function right there, which may or may not be a function. I'm pretty sure that it's not, because a fourth degree function is usually going to make something like a U shape or possibly a W. I don't think that's one-to-one. It's probably not going to pass the horizontal line test, so its inverse wouldn't be a function, but that's beside the point. What I like to do on a problem like this is think about the ordered pair that we're talking about here on the left, f of x, and then the inverse of that ordered pair that we're dealing with here on the right side. And this value here that we're given here, that a value is an x value in the inverse right over here. This ordered pair is 8 comma something. Now, since the left and right side of this t-chart deal with inverses, the sister point of this ordered pair, 8 comma 0, 8 comma something, would now have 8 for its y coordinate right over here. But what we don't know is what this one right over here and this one right over here are. Okay, so that's what we've got to work on. And this is something that bothers people a little bit. Now, remember, I'm going to ask you guys to do problems like this without a calculator. So solving this one is going to be a little bit weird. The promise I'm going to make you guys is that these particular problems right here are going to have nice solutions that aren't all that difficult to find. You're going to be able to basically hunt for them and see if they work. So here's what I'm going to do, guys. I'm going to start guessing numbers. For example, 0 is always the easiest number to work with, but let's see if 0 actually gets us 8 here for a y value. Well, 1/8 times 0 would be 0, plus 0 minus 0. That does not get us 8. That gets us 0. So it wasn't 8. Let's try that again. So how about a 1? Now a 1 isn't going to work out well here, because 1 to the 4th is 1 multiplied by 8. That's going to give us a fraction then. And then when I keep going here with a whole number and a whole number, this y result is still going to be a fraction. 1 is not going to get us 8 either. So let's keep going then. Let's try 2. 2 to the 4th is 16. 16 divided by 8 is 2. This is promising. And then plus, let's see, 2 cubed is 8, times 2 is 16, minus 11 times 2 is 22. 18 minus 22, is negative 4, not 8. So it wasn't 2. All right. Oh, doggone it. I think I did that thing again, and I think I just lost. Oh, wait a minute. Hang on. Let's see. Oh, good. We're not in bad shape. So what did I learn there, guys? It wasn't 2. All right. Now, let's keep trying a few different things. 3 would probably be the next number you'd think of to try, but just like 1 wasn't going to work, 3 is going to stick us with fractions here as well. 3 to the 4th is what? 81. 81 doesn't divide evenly by 8, so that would get you fractions as well. Whew, let's try 4 and see where that gets us. 4 to the 4th power? Oh boy, that's 256. It's 256. That 256 divided by 8? Let's see, can I do this in my head? That's cutting in half 3 times. 128, 64. I think that's a 32 from that first term there. Plus 4 cubed is 64. 64 times 2 is 128. And then minus, what do we got right there? That 11 times 4 is going to be a 44 there. That looks way too big, doesn't it? All right, so at some point then, we probably want to start working in the opposite direction. I don't think this one's going to work either, though. That's what, 160 right there, minus 44. That doesn't get you 8 either. So let's forget about that 4. That one didn't work either. Okay, let's remember something, guys. Let's start putting some negative numbers in there and see what that one does for us. The negative 2 to the fourth is 16. 1/8 of 16 is still going to be 2. Negative 2 to the third power is negative 8. Negative 8 times 2 is a minus 16. And then a minus 11 times a negative 2 is going to be a plus 22. 2 minus 16 is negative 14. Negative 14 plus 2 gives us the 8 that we were looking for. That was a hard one. We had to dig for that. So negative 2 is the x value that we're looking for. So let me just kind of clean this up. I'm going to write that in blue here. Negative 2 is the x value on the left, which also means it's the y value on the right, but that's not really relevant. Now, where are we going with this? We're really interested in what happens when x is equal to 8 in the inverse. When x is 8 in the inverse, that means that y is 8 in the original function, and our x value there is negative 2. So here's what we're going to do, guys. We're going to take the derivative of the original function, so f prime of x, and that one should be pretty straightforward. The 4 times the 1/8 is a 1/2 x to the third power, and then a plus 6x squared minus 11. We evaluate that derivative not at 8, you guys, but at this x value right here, f prime of negative 2. Let's see what that does for us. Negative 2 cubed is negative 8. Half of that is a negative 4. And then a plus negative 2 squared is 4 times 6 is 24 and minus 11. So that's going to give you 20. 20 minus 11 is 9. And now the big takeaway from what our problems in our notes should have told us right here is that we can avoid trying to find actually what the inverse of this function is and then taking the derivative of that inverse. It'd be very difficult to do, and we can work our way around it this way. The notation bothers people a little bit, but what we now know is that the derivative of the inverse of f taken with respect to x evaluated at the spot where x is equal to 8 is always going to be the reciprocal of this number right over here, not the opposite reciprocal, just the reciprocal, and that is going to end up being 1/9. So that's the way we handle a general inverse derivative problem here, guys. We make the t-chart. Okay, we set up this x value over here on the right of whatever they gave us. It becomes the y value on the left, and this is really the hard part, figuring out what x value will make f equal this value right here. Then we take the derivative of f, we evaluate it at that new value right there, and then we reciprocate that value, and that 1/9 then is the answer to this problem here. I gave you that worksheet so that you guys would get some practice at this skill because it's pretty difficult to do, but hopefully after a while you guys will start to get the hang of how that works.